All right, we're back. We are game 3001 in the summer 2019 semester at George Brown, Artificial Intelligence. Week 3, part 3 of our challenge, part 2 of our challenge. That's what it is. Let's take a look. So again, what we had last time was something that looked like this, where we can change direction and kind of move towards, wherever we want to do manually, right? Now what we want to do is we want to do this automatically, right? So, of course, we want to use the seeking behavior that we've kind of talked about here, a very simple seek, right? So we know the target direction, and here in this area, normally we'd set the velocity, but what we want to do is, we don't want to do that here. We want to, in fact, try to figure out what the desired direction is and turn in that direction, depending on if we're to the left of the target or to the right of the target. I want to kind of turn left or right, and then I want to move either way. I want to move forward either way, okay, on the direction I'm pointing. So if that's the case, we'll leave this commented out. We'll leave this desired direction here for now, but I will also comment this out just so that we can come back to it if we need to. And I'm going to do this. If my desired direction minus my current direction is greater than 0, so I'll keep this part. So if that's true, right, then what I want to do is I want to turn to the right, right? Turn right. Otherwise, we'll say else if, and we'll do the same thing. We'll be very explicit here, so it's only one or the other. If my desired direction minus my current direction is less than 0 somehow, right, they want to turn left. Let's just try this part first. So no motion forwards. I just want to automatically turn towards my target. Let's see what that does. This is the first problem, right? So it automatically turn towards my target. And if I move my target up or down, or whatever, later on, we should be able to seek to it. Okay, part two. Now I want it to move. Well, I want it to be able to pull off the move function. So move every frame after that. So let's try this. And let's see what happens. And it's go. So why did it do that? Why do you think it went like woo, woo, and then it kind of took off? So the fact that it took off was pretty bad, because that means that the angles are all messed up, right? The fact that it actually went there and didn't stop, well, the reason why that happened was because of our check bounds. Our check bound sets the velocity to 0, but we're not using velocity right now. We're using max speed. So what I want to do is set the max speed to 0. So I'm just going to comment this out for now. And we can go down here and say our max speed, so m underscore max speed, well, that's equal to 0, right? If the distance between the target on the x-axis, well, that can't be. It's got to be both on the x-axis and the y-axis. It's got to actually be on top of it. They've got to be in the same location, both on the x and on the y, right? So if I was going to do that, I want to kind of open up these brackets, and then what I want to do right now is I want to put these ampersands, and grab this whole thing, and I'm going to look at the y-axis as well. And close it off. So if the x-axis or the y-axis, and both of them have to be the same, if they're less than or equal to, well, that's bad, less than or equal to. They've got to be very close to those things, right? It's almost like I want them to be within a certain area, a range. Instead of just like less than that, it's like my position minus my x and my position minus my y. It's almost what I'm doing here, which is down in here, right? So down in my position, where I did this position stuff, my where the direction is my my current direction minus the target direction, This kind of stuff here is what I really want to do up there. And I can do that on both the x and the y. I can say that they're greater than or equal to 0, something like this, right? So I can say that if my position x minus the position x, so one of these, right? And I want to kind of have like the absolute position, right? Because that's what I didn't do in the first one, right? So if you notice, I'm subtracting one from the other. I want to compare the distances between these two things. Almost like, hey, here's my position, and here's the target position, right? If the distance between this is less than, let's say, 2 pixels on both the x and the y axis, the distance, right? Stop. If it's that close. Otherwise, and I'm saying 2 pixels is a buffer, a threshold, something like that. So I could write it like this, or I could use the distance function that I made. So let's do that. So let's just get rid of all this. And I could say that if util, and then I can say distance. And again, I can use 2 vectors. So the current position, right? And my target position, so get position, that's the first vector, and my target position, which is m underscore target, or what I had before, which is this big line of code over here, this one. If this, the distance, I'm using the distance function here. Now the distance function is, it's Pythagorean distance, so it's like, it's pretty expensive, but for now, it'll be okay, is less than or equal to 2.0 f, so some small amount, like less than 2 pixels. Then what's going to happen is I want the maximum speed to stop. I don't want it to go anywhere anymore, okay? So let's see if that works a little better than my other functions, the way that the other statement worked out. The distance between the two. So if I was to do that then, and now it ran away with me and it took off forever, right? So that was weird, right? That was really weird. So what happened? Did check bounds get called? What's the distance between my position and the position of my target? Let's print that out, right? So I hate to do this, but I mean, I'm going to have to check my application here. So I'm going to try and do one of these. And actually what I'll do is I'll say distance. So let's make a float that's called distance. This is all the checks that I have to do, is equal to this, right? And then I'll say if distance is less than or equal to 2f, right? Then max speed is equal to 0. So what is the distance, right? What is the distance? Is it ever less than or equal to 2f? Or does it have to be a bigger number over here, right? That is an expression. Distance is less than or equal to. Might be a thing. It is. A Visual Studio thing. All right, well, let's see what that is. And if I want to show what the distance is, I can certainly, in here, I can show the distance. I can do something like a cout distance, and then put in the distance in there that I want to show, and then do the end line character. All right, so 200s, it's really big. And was there any time where it was small, like really small? It looks like it was massive. The distance between the two objects are like 500 and 1,000. Now it's growing, of course, right? But you can see that initially it was 400, you know, and either the distance calculation is wrong, but sometimes it was really close, like 90. There's one time it was 4. Look, it came as close as 4, and then it turned away again. Let's give it a threshold of like 5. Maybe 2 is too little. 5 pixels. Let's try it again. Yeah. So that kind of captures that part, right? And now you can see that the distance is less than 5. The reason why it has to be a threshold, like a buffer, is because I'm moving so fast, how many pixels per frame, as an example, and I might overshoot faster. I'm already past the check before I pass through it. But you see how it came up and it came down in here, right? So let's do another check. Let's move our object. So our object right now starts at 500, 100, which is to the right. Let's move it down to the bottom right. So I'll start it way down here. And let's see what that does. We can actually see our object a little better. So again, it starts down there now, and boom. That's pretty good. So see how it kind of, took a circular path? But does that circular path make any sense? Let's take a look. Right? So it kind of came up and then turned towards this way. Now, why is the path that way? The path is that way because of A, my maximum speed, 10, and B, my turn speed, which is 5. Now, by the way, I have to mention this. There is no linear interpolation here. The movement between point A and point B is linear. That means it's moving the exact same speed. It's not speeding up and slowing down like we want to see with a rival, right? And it's a little bit, my turn speed is 5. If I made my turn speed 10, make my turn speed 10 here and see what it does. So let's do this, turn speed 10. You can see that it turns much faster. And if I made my speed slower, let's say I move my speed at 5, you can change these values, then you can see that it's going to have a weird shaky pattern. So why is this shaky pattern happening? Why does it do this? Because it's trying to approximately find the correct angle. And so we see that this is still an issue. There's still some problems with this thing, right? But we're on our way to getting a little better. So let's move this back to 10. Turn speed is 10 is fine. We can make it 5 if you want. 5 means it's going to go farther before it turns. So if I made it 5, then it would be like, kind of further out before it came over, like that. So far so good. I think we're getting there in terms of how it's looking. 100% satisfied in terms of how it's stopping and what it's doing. But I think in the beginning it's pretty good. Now let's see. This is the ultimate test. The ultimate test is, can we re-enable our target moving and stop enabling the moving for our ship? And let's see if it continues to seek our target when we move it around. All right, so let's try that. So again, I'm going to go up to our input manager, and I'm undo some of the stuff that I've done already, because I don't want to move my ship manually anymore. I want to move it automatically. So I want to put this back. I want to get rid of this. Oops. Try that again. Get rid of that. And I want to put this back. So again, I have my controls. We're going to change this back to target in a second. Right now it says ship. Pull this back, kill this. Kill this. Pull this back. Okay, and put all this back. Okay. But we have to change all these to where it says M ship to M target, because we want our target control back. So again, M_P target is what I want in there, and I can just copy paste. Make sure you don't do any copy pasting errors, and you should have control of your target back momentarily. Remnants. And again, this is just so we can play with the target, move the target around, and make sure the ship doesn't get there. All right, so if I did that, and if I did this, and if I move my target now, so I kind of move my target down, you can see that it comes back, and it comes back around, and it comes back around, and it'll keep coming back around. This is interesting, and forever, right? Why is that? Because it's trying to find a path. This is where we have a problem. Our target, and again, even if I move my target somewhere closer up, you can see it seeks down, right? And tries to hit my ship. So almost like swooping down, right? My target is trying to find the position of my target And then based on my different behavior, right, than we saw earlier. Based on my current position and the speed. So it's turning, it's moving, and it's going to come back based on the speed of the object, right? And now if I move, it's not going to move because the max speed is 0. Let's try that again. So again, I'm going to move this out, and let's just do one of these. You can see that the target is still seeking, and it got me, right? If I slow it down, again, if I go back to my ship, and I slow my ship down, so instead of my max speed being 10, let's move my max speed to 5. My turn speed, let's make my turn speed a little faster so it can seek me out a little faster, but it can't catch me as fast. So there, you can see how it's moving, and it's trying to get me, and it's trying to do stuff. It's moving around, it's trying to circle, and it's trying to get me almost there, right? It's almost got me, right? And then it kind of doesn't have me, especially when I move at an angle like this, which you can't do. When I'm close enough, it'll stop. Now, why does it do this left and right movement? Because angle that it's trying to figure out where I am and where it is different. And this is where we have to do some more troubleshooting to fix that problem. Because really, I've got a very simple algorithm. All it's doing is checking to see if the target's to the left or the right, left or right, and then moving left or right. I mean, it's not exactly what we want in a seeking algorithm, and we're going to fix it next week. We'll make it more intelligent the way it works. But for now, what we have is some very basic seeking behavior. That's kind of weird. And notice how it's doing that little dance back and forth. It's doing that dance because the values aren't exactly what they should be, and that's why it's dancing around. And because of this, greater than 0, less than 0, and it's like, you know, it's got a framework. I could make it a different number, greater than 1, less than 1, you know, kind of thing. Greater than or equal to 1, so zeros don't matter. Some kind of range of numbers that might be better to turn left and turn right. But again, for now, you know, it's pretty good the way it is. If I make it a little faster, this is a turn speed of 10. If I make it slower, right, you can see that you still get a bit of jitter, but it kind of finds you. And if I make it slower even than that, like let's say a turn speed of 2, so really slow turn, you can see that the path is way longer, right, but a little bit smoother. 5 seems to be a bad number for it somehow. Again, I'm also running this in debug mode, so you're going to see a little bit more problematic calculations. Let's try that again one more time. Now I'm moving around. So again, I'm moving it around. It's trying to catch me, but it hasn't got to me yet, and then it seeks me out. Okay? Once it's got me, though, it's pretty much game over. I can't do anything about it. So again, I can move around. And there's a point in time where if I'm down in here somewhere, it'll keep on doing some weird dance. Watch. Right there. And if I come close enough to it, maybe it'll come back. But the reason why I went off screen is because of that deadly spiral, left, right, straight. Keeps going straight, right? Because it's neither greater than or less than. It's some other value, right? And it's probably on a, you know, kind of a very skinny path. It's probably like near 0. We can correct that. One more time. Okay, turn around, right? So it seeks around, and right. Calculating the new position. And there it goes. It's like when it leaves the screen, it's not really liking it too much when it does that. And there it is again. I kind of saved it. So that's our little seek behavior, and there it is. Again, these are all because of the properties we've assigned for the speed and direction change. The faster the speed and the direction change happens, the quicker it can make a turn, so it can find me faster, right? And the faster I run away from it, then the more challenges it has, because what it's doing is it's constantly calculating if I'm to the left or to the right. The challenge is when I'm not neither to the left nor to the right of it, but right directly in front of it or directly behind it. And this is where the challenge is. What happens in those cases? In those cases, we can also solve using another set of algorithms. So today, for your exercise, for your lab 2, in order for you to get lab marks for today, I want you to work out this problem, the 2 challenges. I want you to package it together, right? I've already given you the solution. Package it together and upload it to Blackboard, right? A zipped version of your solution, so like we did last week, right? I want no garbage files. Please don't give me the garbage files. Don't make it like 50 megabytes, like to download or something crazy like that. I'm going to check these. I'm going to check last week's too. But all I'm looking for is if your files work and if you put some honest effort in, I'll give you some marks for it. Okay, that's what I'm looking for. It's just practice, yes. The what? On how to submit it? You want me to put that in there for you? Like, do you want me to know? I mean, it's recorded too, right? Okay, I'll put that in the instructions for you. Okay. All right, that's it for me, guys. Next week when we come back, we're going to do more of this stuff, and I'm working out with Alex what your assignment's going to look like. We were just talking about it just now to make sure that it's right. Again, I don't anticipate it's going to be very difficult. I want to include seeking behavior, fleeing behavior, arrival behavior, some kind of wandering, those kind of things. And you can get all that stuff. You'll have to learn how to do that all on your own, right? That's why I'm showing you this, so that you can figure out, okay, if I want to do fleeing behavior now, so I have an object and I want my object to run away from it, how do I show that? How do I show fleeing behavior, right? Well, what arrival does is it slows down as opposed to moving in a linear way. Right now, it's moving very linearly, right? And the arrival just kind of, circles back and does it almost like more frames near the last part. So it's almost like an easing function. That's what it does for an arrival, as opposed to a linear movement, which is what it's doing right now. Right now, it's moving the same speed throughout the entire process. Okay. Questions for me? Okay, guys, so you have your lab 2 is due tomorrow by midnight. Okay, as long as you get it done by midnight, we're good to go, yes? Exactly. That's what it's for, more than anything else. And what I'm trying to do is make it so that you practice. If you don't practice, these are all worth 1% of your final grade, right? I'm going to do one or as many as I can. Some of them are going to be worth more. Like if I do more, it might be something more, hearty, a little bit more beefy. Like this one's not very beefy. I'm just getting you to do what I'm doing, right? Then they'll be worth more than 1%, right? But for now, not a lot of thinking here. It's literally just trying to, figuring out how the framework works. I really want you to get your, good sense of how it works. And I think some of you have that. I don't think some other people do, right? And I'm kind of concerned, not just this class, but the other class too. It's a bit of a challenge, the SPL framework, plus you're learning, behaviors, movement behaviors, movement patterns for AI. It's a challenge. And we haven't even talked about state machines or, player state. Because right now, think about that. We talked about this morning in lecture that there's different states you can be in. Seeking state, an arrival state, an idle state, a fleeing state, and so on. And those things we're going to talk about later on when Alex works with you guys in the second half. Okay? That's it for me. I'm going to stop recording now, and I'll see you guys next week.